At the 74th International Astronautical Congress held in Azerbaijan, SpaceX founder Elon Musk was named the laureate of the prestigious IAF World Space Award for 2023. On October 5, during a live discussion session at the Congress, Musk gave updates regarding the future of the Starship rocket. Let's take a look at the new and key information Musk revealed during the event. When asked what the expectations were for the second Starship flight, Musk stated that if the Starship reaches stage separation and there is no explosion like the first flight, the vehicle would complete the suborbital mission with the Starship upper stage splashing down in the Pacific Ocean.
Well, I do want to set expectations not too high. There's a tremendous amount of new technology in this rocket. We have actually changed the entire stage separation system. With Flight 2, we're actually trying to do hot staging. So hot staging would mean that we light the ship or upper stage engines while the boost engines are still partially thrusting, essentially blasting the top of the booster with the ship. If the engine's light and the ship doesn't blow itself up during stage step, then I think we've got a decent chance of reaching orbit. It's going to do almost a complete circle of the Earth, but then splash down somewhere in the Pacific, just off the coast of Hawaii.
Regarding catching ships and boosters using the launch tower arm, Musk said that there will be a few flights where the Starship will land in the ocean before they try to return to the landing site. And SpaceX hopes to catch boosters using the tower next year.
For the ship side, we obviously want to make sure that it actually comes in fully intact and lands at a precise location in the Pacific before we try to catch it at the launch site. Obviously, booster flights we've done many times on Falcon 9, so we're much more familiar and have a much higher confidence with booster recovery. There's a decent chance, depending on when our licenses are granted, that we would catch the booster in the next year or maybe less than a year.
Musk believes that if all goes as planned, an uncrewed mission to Mars with Starship is feasible within the next 3 to 4 years. Regarding the human landing system version of the Starship that will be used for the Artemis missions, Musk said that the Starship can land on the Moon with minor design modifications compared to landing on the Earth or Mars. Musk also revealed details regarding SpaceX's future Starship plans, such as the propellant transfer demonstration mission, repurposing Starship as a commercial space station, Starship Earth-to-Earth transportation system, and also using the vehicle to launch large space telescopes. You can watch the full live event from the link given in the description. SpaceX is currently seeking final regulatory approval for the Starship's second integrated flight test from the U.S. Federal Aviation Administration and the Fish and Wildlife Service. The authorities are currently undertaking a final safety review of the launch vehicle, as well as a review of the environmental impact of the latest upgrades to the Starbase launch site. According to reports, the review process could take anywhere from 30 to 135 days to complete. On Thursday, October 5, teams at Starbase destacked Ship 25 and Booster 9 for reasons currently unknown. Before the destack, on October 3, Ship 25 and Booster 9 conducted flap and grid fin actuation tests to ensure the aerodynamic control surfaces of both the ship and the booster were performing as intended. The installation of the newly delivered large water storage tank has been completed lately, increasing the water storage capacity of the deluge system. A deluge system water discharge test can be expected in the coming days, primarily to evaluate the newly installed tank and its plumbing and valves. While Booster 9 and Ship 25 await the launch, SpaceX is busy building and testing new prototypes for future flights. Starship 26 is currently being prepared for static fire tests on suborbital launch pad B. We will witness Ship 26's 6-engine static fire test in the near future. After completing 2 cryo-proof tests, Ship 28 is currently resting on an engine installation stand near the rocket garden. Teams are working on the ship to get it ready for the next round of pre-launch tests, which will include static fire tests. The ship is yet to receive its all 6 Raptor engines. Ship 29 and Booster 10 have recently undergone cryogenic proof testing at the Massey's test site. Ship 29's first 2 cryo-proof tests happened last month. The ship's methane and oxygen tanks were completely filled with supercooled liquid nitrogen before detanking during the first test on September 26. In the second test on September 27, only the oxygen tank was completely filled with liquid nitrogen, while the methane tank was only partially filled. The third cryo-proof of Ship 29 happened on October 4. Both the methane and oxygen tanks were partially filled with liquid nitrogen this time before detanking. All 3 tests appear to have been successful, and if no additional cryo testing is required, Ship 29 will be returned to the build site for engine installation. Booster 10, which has completed a total of 4 cryogenic proof tests at Massey's, is currently inside the Mega Bay, waiting for its 33 Raptors. Ship 30 was fully stacked inside the high bay in August. The vehicle will be cryo-tested at Massey's site very soon. The aft section of Ship 31 was moved into the high bay early Tuesday morning. The ship was lifted and joined with the aft section a few hours later, completing the stacking operations. Next, teams will install the aft flaps, connect all wiring and plumbing, and finish installing the remaining thermal protection system tiles. The ship will be ready for cryo-proof tests at Massey's once those works are completed. Booster 11 and Booster 12 are also inside the Mega Bay, along with Booster 10. Both Boosters 11 and 12 are yet to begin their cryo-proof test campaign. Booster 13 stacking operations have also begun inside the Mega Bay. The booster received its methane downcomer on October 4. It's the tube that runs from the upper methane tank through the center of the lower oxygen tank, allowing liquid methane to reach the booster engines. The aft section of Starship 27 was transported to Massey's on September 27. Ship 27, without flaps and thermal protection tiles, resembled Ship 26 after stacking. The vehicle was cut in half and subsequently scrapped in July when its common dome collapsed, most likely owing to a pressure drop inside the methane tank. While practically everything was scrapped, the vehicle's aft part was left intact. It was later relocated to one of the old production tents for some design modifications. Let's discuss the modifications the aft section received with the help of this article posted by the Ring Watchers. The quick disconnect interface was removed from the aft section, and numerous wires were attached to its side. SpaceX replaced the engine shielding inside the aft section with a much more robust design meant to withstand the intense conditions of hot staging. Cover plates were also installed in the locations of the Raptor engines to seal off the area. After arriving at Massey's, the aft section of Ship 27 was lifted and placed inside the structural testing cage, which was previously used to structurally verify the design of Starship nosecones. It looks like SpaceX is planning to conduct structural tests on Ship 27's aft section, especially on the newly redesigned engine shielding, to check if they can withstand the increased forces that will be experienced during hot stage separation in flight. The structural testing cage has pistons inside to simulate the stresses the aft section will experience during an actual flight. The test results will aid SpaceX in redesigning the aft section and engine shielding of future Starship prototypes. A test tank labeled Ship 24.2 was moved to the Massey's side on September 29. The test tank consists of a Starship aft section, a payload bay section, and a forward section with an elliptical dome and stringers on the exterior. The test tank will also most likely be subjected to structural tests inside the test cage to see if the payload bay can withstand the forces that will be experienced in flight. The payload bay cutout is one of the weakest regions in a Starship structure. Ships 25 and 26 have already had their doors welded shut, indicating that they will not be carrying payloads to orbit during test flights. Ships from Ship 28 onwards now have a functional payload bay. The test results from Test Tank 24.2 will give SpaceX the required data to determine if those payload bay designs will survive the stresses in flight. If the test results prove the design is weak, SpaceX needs to make necessary adjustments to the payload bay before Starships can carry payloads, especially the larger and more massive second-generation Starlink satellites. To everyone's surprise, a Tesla Cybertruck arrived at Starbase on October 3. It spent many hours at Starbase, visiting both the build site and the launch site. SpaceX teams towed a Raptor vacuum engine with the Cybertruck around Starbase for a video shoot, also showcasing the vehicle's massive load-carrying capacity. According to Tesla, Cybertruck offers a payload capacity of 3,500 pounds, or more than 1,500 kilograms. Now, let's discuss some of the latest updates from the world of science and technology. SpaceX has won its first contract with the U.S. Space Force to provide satellite communications via its Starshield satellite constellation. SpaceX announced last December that they are expanding Starlink satellite technology into military applications with a new business line called Starshield. Starshield will employ the same high-speed broadband technology as SpaceX's Starlink satellite constellation, but will be tailored toward government use, specifically by the United States military and its allied agencies. The service will offer a higher level of security than Starlink, featuring additional high-assurance cryptographic capability to host classified payloads and process data securely. The Starshield service will have an initial focus on Earth observation, communications, and hosted payloads. Moreover, Starshield spacecrafts will also be interoperable with other satellites, such as Starlink's, that are equipped with a laser communications terminal. The one-year contract that SpaceX signed with the Space Force has a maximum value of $70 million, and this is the first known contract for Starshield. The contract is expected to support over 50 mission partners across all arms of the US military. SpaceX launched 22 more of its Starlink V2 mini satellites into orbit atop a Falcon 9 rocket from Cape Canaveral Space Force Station on October 5. The mission, dubbed Starlink Group 6-21, marked SpaceX's 70th orbital mission of the year. Stage separation happened 2 minutes and 30 seconds into the mission, and as per plan, the Falcon 9's first stage returned to Earth for a vertical landing on a SpaceX drone ship stationed in the Atlantic Ocean. It was the 8th successful landing for this particular Falcon 9 first stage. The 22 Starlink satellites, meanwhile, were deployed from the rocket's upper stage about 65 minutes after liftoff. SpaceX has launched 5,222 Starlink satellites to date, of which 4,864 are currently in orbit. The next Starlink mission that will carry 21 V2 mini satellites into space is scheduled for liftoff from Vandenberg Space Force Base on October 7. United Launch Alliance and its Atlas V rocket are ready to launch prototype spacecraft for Amazon's Project Kuiper, a satellite network that will provide fast, affordable broadband to unserved and underserved communities around the world. Amazon is planning to put the first two prototype Kuiper satellites, KuiperSat-1 and KuiperSat-2, into a 500-kilometers orbit during the mission, dubbed Protoflight, scheduled for liftoff on Friday, October 6, from Cape Canaveral Space Force Station in Florida. The satellite prototypes will add real-world data from space to years of data collected from lab and field testing, providing additional insight into how the end-to-end Project Kuiper network performs across ground and space. The Kuiper system includes three key elements: the advanced low Earth orbit broadband satellites, small and affordable customer terminals, and a secure, resilient ground-based communications network. The Protoflight mission will put all three aspects to the test, as well as the teams and systems that manage them. Amazon began research and development on Project Kuiper in 2018. In July 2020, the U.S. Federal Communications Commission granted Amazon a license to deploy its planned constellation of 3,236 satellites in low Earth orbit. The deployment will take place over the next 6 years, and internet service will begin once the first 578 satellites are operational. Amazon has signed launch contracts with United Launch Alliance, Ariane Group and Blue Origin for a total of 92 rocket launches in order to build out the entire constellation. Project Kuiper plans to deploy service to many countries around the globe at a speed of up to 1 gigabit per second. NASA is one step closer to Artemis II, the agency's first crewed lunar mission under the Artemis program. Teams at NASA's Michoud assembly facility have structurally joined all four RS-25 engines onto the core stage of the Artemis II Space Launch System moon rocket. Two of the RS-25 engines are recycled from NASA's Space Shuttle program, while two are fresh engines with recycled hardware inside. Together, the four engines will provide 8.8 meganewtons of thrust for 8 minutes of SLS's flight. Given that the engines are now joined with the core stage, NASA engineers will focus on the complex task of fully securing the engines to the stage and integrating the propulsion and electrical systems within the structure. Meanwhile, all 10 segments of the Artemis II SLS rocket's solid rocket booster arrived at Kennedy Space Center on September 25. All the segments will be moved into the vehicle assembly building one at a time in the coming days, where they will get stacked to form each of the 54-meter-tall boosters that flank each side of the rocket. The boosters together will produce 32 meganewtons of thrust, more than 75% of the total thrust at liftoff. After completion of the booster assembly, engineers and technicians will integrate the rocket's core stage, followed by the upper stage and the Orion capsule. After its pieces are put together, SLS will be tested at NASA's Kennedy Space Center Launch Pad 39B ahead of the actual launch. The Artemis II mission, slated for November 2024, plans to send 4 astronauts on a lunar flyby in an Orion spacecraft for a maximum of 21 days. The Artemis II crew consists of Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen. Assuming Artemis II goes as planned, the follow-up mission, Artemis III, will land astronauts on the moon as early as December 2025. Thank you for tuning in for the latest science news and Starship updates. If you enjoyed this video, please hit the like button, leave a comment, and share it with your friends. Also, don't forget to subscribe to the channel and turn on notifications so you never miss an episode.